In this video, we're going to continue our work with trig equations and look at solving quadratic equations in sine theta, cos theta and tan theta. We're going to consider a range of different scenarios and look at possible techniques that we could use to solve a given equation. Whilst the video won't be exhaustive, it should give us now enough skills to move forward and answer some more challenging questions. Okay, let's go ahead and start with a basic example. What we're going to have is a quadratic equation in cos theta. And we'll have now 4 cos squared theta minus 1 is equal to 0. So remember, this is cos theta squared, or if we want, cos squared theta. Generally, this is the notation we use. Let's now take theta, and we're interested in theta. Let's now pick a nice easy interval from 0 to 360 degrees. We can use lots of the skills that we built up in topics on algebra to solve this particular equation. So for example, now if I wrote 4x squared minus 1 is equal to 0, we've got two choices. We could write that as the difference of squares and factor it, or we could add 1 to both sides and divide by 4. That would give us x squared is equal to 1/4. Taking the square root, x would be equal to plus or minus 1 over the square root of 4, which is going to give me 1/2. When we're solving 4 cos squared theta minus 1 is equal to 0, we would do exactly the same. It's very important that we don't lose solutions. Sometimes students are likely, or have in the past, just put, well, x is going to be equal to 1/2, so cos theta would be equal to 1/2. If we drew the graph, let me just draw y is equal to cos squared theta. Now, as you can probably imagine, if we drew cos theta now between 0 and 360 degrees, we would end up with something that looks like that. Clearly, if we have cos squared theta, what we're going to have now is the negative part here being positive. So we're going to end up with that. So this now, the white one, let's just put the red one on top. That's going to do something like so. And of course, this will still be periodic. So this is going to cycle as before. So let's just write this on. So the white one is y is equal to cos theta. And we've got here theta between 0 and 360. And the red one is going to be y is equal to cos squared theta. So if I consider where y is equal to, with y is equal to cos theta, if I said where is cos theta equal now to 1/2, what we'd have is the following. We would have a solution here and a solution here. We can see in this particular case, if I've got cos squared theta, I'm going to have 4 solutions. In the same way now, if I have cos squared theta is equal to 1/4, we need to consider the solutions that we're going to get. So if I continued now, again, this would be periodic and we would end up now like so. So all it would do is cycle infinitely to the left and infinitely to the right. At this stage now, I'm going to go ahead and solve this. When these get more tricky, you can make a substitution. So when we get quadratics in the form a cos squared theta plus b cos theta plus c is equal to 0, we can just make a substitution and say let p be equal to cos theta. I'm not going to do that, I'm just going to go ahead and solve. So I'm going to say that cos squared theta will be equal to 1/4. Therefore, cos theta will be equal to the square root now of 1/4, which is going to be plus or minus 1/2. So that's what I end up with. So let's consider now cos theta is equal to 1/2 in the interval now from 0 to 360. We know that this is one of our special angles, so we can say that theta is going to be equal to 60 degrees. And by symmetry, we can say it's going to be 60 back from 360, so that's going to give me 300 degrees. If I then look at cos theta is equal to minus 1/2, we can say that theta, and again, this is one of our special angles, we're going to have now 120 degrees, and then 120 degrees back from 360, and we got 240. I'm assuming after the amount of videos we've done, you're fairly comfortable now with the symmetry of the cosine curve. If you wanted to look at this on the cast diagram or unit circle, we're going to have one just here, that's the 60, and by symmetry the other one will be just here, that's now the 300. And then we'll have the other ones now, let's put that on, and that's going to be 120, and then we're going to have now 120 back from 360. So this is one way of looking at it. We've got this one right here, which is a 60-degree angle. We've got now the 120, and then we consider coming back 60 and then coming back now 120. It's entirely up to you. Or you can simply write now that cos x will be equal to cos of 360 minus x, and just use that property. So there's a nice example and a fairly straightforward quadratic. We need to consider the positive and negative roots of that equation. What we're doing is solving for cos theta. Of course, if this wasn't a nice number, we would take the inverse cosine, get a principal value, and consider subsequent solutions. So for example, now if I had, let's write this down, let's say we had 3 cos squared theta, 4 cos squared theta minus 3 is equal to 0, then we would end up now with this one right here. This would give us cos squared theta is going to be equal to 3 over 4. We could take the square root of this, and cos theta would be equal to plus or minus root 3 over 2. So again, we have a special angle with that one. But if we didn't have something as nice, let's say we had 7 cos squared theta minus 1 is going to be equal to 0. We could say now that cos squared theta is going to be equal to 1 over 7, and taking the square root, cos theta will be equal to plus or minus the square root of 1 over root 7. And then we would look to do that. So we'd find our principal value now for theta and consider subsequent solutions. So in the calculator, making sure you're in degrees mode, shift mode 3, we'd take the inverse cosine now of 1 over root 7. So this would give us now our principal value, and then of course we would do 360 minus that answer, and that would give us the 292. And then we could do the inverse cosine now of minus 1 over root 7. That would give us now the principal value, and then we would do 360 minus that one to get the other one. So again, you can do it by symmetry, lots of different approaches. Hopefully by now you've chosen a method that you're fairly comfortable with. Okay, let's go on and look at another one. Let's take another equation. Let's take now 2 sine squared theta. So 2 sine squared theta is equal to sine theta. And we will say now that theta, let's again take a nice straightforward interval. Let's say that theta is going to be between, let's do this in radians, 0 and 2 pi radians. Okay, now let's just think about this here. We've got 2 sine squared theta is equal to sine theta. If I divide both sides by sine theta, I'm going to lose solutions. If we consider now x squared is equal to x, and this is just an algebraic equivalent, if I divide both sides by x, I've got x is equal to 1. Now if I wrote this as x squared and subtracted x from both sides, I've got x squared minus x, which we could factor, x minus 1, which tells me that x would be equal to 0 or x would be equal to 1. So what I'm not going to do here is divide both sides by sine theta. I'm going to subtract sine theta from both sides and factor. So what we'll have then is 2 sine squared theta minus sine theta is equal to 0. Common factor of sine theta, so we've got sine theta, and then we'll have 2 sine theta minus 1 is equal to 0. This is a quadratic equation in sine theta. So we can see sine theta is going to be equal to 0, or 2 sine theta minus 1 is equal to 0, which means sine theta is going to be equal to 1/2. So if we consider now sine theta is equal to 0, let's just go ahead and draw the sine curve. And again, you might already know these might be committed to memory. Sine theta is going to be 0 at 0, it will be 0 at pi, and it will be 0 at 2 pi. Or 0, 180, and 360. So 0, pi, 2 pi. So we can state now that theta will be equal to 0. We've got now pi, and we've got 2 pi. Do check the interval. Sometimes you're given a strict inequality, so you might have from 0 to 2 pi, and the 0 is not included. In this case, I've included it. Okay, next one. We've got now another one of our exact angles, a special angle. So that's going to be pi by 6, and then pi by 6 back from pi, so 5 pi by 6. Again, I'm kind of thinking that you are comfortable with solving sine theta is equal to half in the interval from 0 to 2 pi. So take home message from that particular equation is don't lose solutions by dividing through. Now when we say that, it's not always a case. So for example, if we've got an equation in tan, or we've got an equation where we can divide through by cosine to get it in tan, then we could do that, but don't divide to lose solutions. So for example, when I talk about, let's say we've got root 3 sine theta is equal to cos theta, and we're interested now, let's say we're interested in theta between 0 and let's say 360 degrees. Okay, when I say don't divide through, what we're doing here is rewriting an identity. So if I did this, I could say root 3 sine theta over cos theta will be equal to 1. We know that sine theta over cos theta gives me tan theta. This is an identity. So I'm not losing solutions, I'm simply rewriting an identity. So we could have tan theta is going to be equal to 1 over root 3. Now again, that gives us our special angle, and that would give us now a principal value. Theta, principal value for theta is going to be 30 degrees, and then by symmetry 180 on, so we'd have 210 and then nothing else. So that's the difference between dividing through and losing solutions and rewriting a trig identity. Okay, let's move on and look at another one. So all these examples we're going to do are going to be fairly easy to solve in terms of the actual the trig involved. What we're looking at is the techniques that we can use. Let's take a quadratic in cosine. Let's say we've got cos squared theta, and then we'll have minus cos theta, and then we'll have now minus 2 is equal to 0. So this is a quadratic. Now we've dealt in the past with quadratics in the form ax squared plus bx plus c is equal to 0. And we know different techniques that we can use to solve a quadratic. Now essentially what we have is a quadratic in cosine. So we've got a cos squared theta plus b cos theta plus c is equal to 0. At this stage you could make a substitution. So let's go ahead and solve this. Let's take theta, and again, nice straightforward interval. We'll go from 0 to 2 pi. So working in radians, nice bit of practice with radians, but the interval is fairly straightforward. So if you're unsure, what you could do is now let p be equal to cos theta. Okay, with this method, do remember that you're going to have to switch this back. So if we look at this quadratic, we've got p squared minus p minus 2 is equal to 0. This factors, what are we going to have? We're going to have p, then we're going to have p minus 2, and then we're going to have p plus 1 is equal to 0. So let's just check that's going to work. P squared minus 2p plus p minus 2. Therefore p is going to be equal to 2, and we've got p is equal to minus 1. So what we can say then is cos theta will be equal to 2, or cos theta will be equal to minus 1. What I want you to do is look at those two solutions and think to yourself, what is wrong here? If we consider the cosine curve has a maximum value now of 1. What we have here is cos theta is equal to 2. So if we consider cosine theta looks like this. We're being asked, where is this now equal to 2? So where is it equal to that value there? The answer is never. Therefore, we can state that cos theta is not equal to 2. Therefore, that is not a valid solution. So no, or not valid, or no real solutions. So there we go. That's what we end up with. So all we've got to deal with is cos theta is equal to minus 1. Now, if we consider cos theta is equal to minus 1 with our little drawing here, we can say that's going to be a pi. Again, we might want to use a calculator. So let's go ahead and do that. Shift mode 4 if you were unsure. So shift mode 4, you want the inverse now, inverse cosine of minus 1, and we're going to now get pi, 180 degrees. We can see that graphically. So what we've done is solved a quadratic in cosine by using the same techniques of factoring an algebraic quadratic equation. Again, use substitution as long as you're switching it back and as long as you're considering now the techniques that you should use when you're coming to solve cos theta is equal to some constant. Okay, let's look at another one. Right, let's choose one. Let's write this one here. Sine theta plus, and we'll take 2 cos squared theta, and that will be equal to 1. Let's have a nice straightforward interval. Let's take theta now from 0 to 360 degrees. Okay, what we have here is sine to the first power. So it's not sine squared theta, so it's not sine squared theta and cos squared theta, so I can't look to do that. But what I can think about is that identity. So what we've got is sine squared theta plus cos squared theta is equal to 1. That's one of our identities. We want this equation in one trig ratio. A trig ratio is either sine theta or cos theta. Of course, we could try and write this as tan, but that's not going to be a good idea given that we've already got them as sines and cosines. So let's think about what I can do. I know that I can manipulate an identity that's in cos squared theta. We're yet to find one for sine to the first theta. So what we always do is change the squared term. So what I'm going to write is cos squared theta is equal to 1 minus sine squared theta. So in the very first video in this unit, when we looked at trig identities, that is one that we used. So I can now write this as a quadratic in sine theta. So I only have now one trig ratio. So 1 minus sine squared theta, and that's equal to 1. So doing a bit of rearranging, we're going to have minus 2 sine squared theta, which I'm going to add to both sides. We're going to have now minus sine theta, and then we're going to have now, what's that going to give me? Minus 1 is equal to 0. Does that factor? I think it will. And I'm just going to write this now. Let's see if this factors. 2s, and that's just for sine theta, 2s plus 1. And then what are we going to have? We're going to have s sine theta minus 1 is equal to 0. So all I've done is denoted sine theta to be s. So let's see if that works. 2 sine squared theta minus 2 sine theta plus sine theta minus 1. So that factors. So at this stage I can write the following. So I can write now, if 2 sine theta plus 1 is equal to 0, then sine theta will be equal to minus 1/2. Or we've got now sine theta minus 1 is equal to 0, so sine theta would be equal to 1. Again, we've got nice, straightforward, exact values to go ahead and solve for, so these are not going to be messy, and we can just consider those. If you want to find them on a calculator, you can do. If you want to consider them now by symmetry, you can find them that way, or we just take them to be exact values. So what we're going to have one here, and I'm starting now with minus 1/2. So if you're using the unit circle, or you're using the properties now of sine theta, that's entirely up to you. This one is going to be now 210 degrees, and then we'll have one just here, let's go there, and this is going to give me now 330 degrees. Again, if you wanted to find this on a calculator, you could do. What this is going to do though is give us now a value just here. When we take the inverse sine of minus 1/2, it will give me a principal value just here. And that principal value is going to be equal to minus 30 degrees. All we would look to do now is add multiples of 330 on to bring it back into that interval. So if you know these as exact values, you might want to use a graph, you might want to use a unit circle, or you just might want to commit these to memory. Entirely up to you. If we consider now sine is going to be negative in the third and the fourth quadrant, we've got 30-degree angles as we've got now 1/2. So you can think of it like so. You can say, well, that's going to be 30 back. So that's going to be 330. That's going to be 30 on from 180. So that's going to be 210. Or you might simply put this into the calculator in degrees mode, shift mode 3, get a principal value. So inverse sine now of minus 0.5. This will give us minus 30. If we consider now, if we now have minus 180 minus that value, by symmetry we will have the other one, which will be now here at minus 150, and then you can add multiples now of 360. So we've got minus 150 minus 30, and then all we're doing is jumping forward 360 degrees into the interval. So lots of different ways to think about that, and that gives us now the solution. So we can say that theta, in this particular case, we're going to have now theta will be equal to 210 degrees, and then theta is going to be equal to 330 degrees. Sine theta is equal to 1 in the interval from 0 to 360. only one of those, and that's where theta is equal to 90 degrees, and we have a nice straightforward value. So that's using an identity to solve a quadratic. We look to put the quadratic in either sine or cosine, and we manipulate the squared term by using this identity here. Okay, let's look at another one. Let's say we've got, let's go for the following one. Let's say we got let's go for sine theta, and then we'll have this equal to 2 sine theta cos theta. When you come on to your later studies, you will see this as a different identity. For now, I'm going to assume that you don't know it, and we will take it from 0 to 360. You're not at this stage expected to know it. Okay, if I divide both sides by sine, I'm going to now lose solutions. So what I'm going to do is write this as sine theta minus 2 sine theta cos theta is equal to 0. And I'm going to consider factoring sine theta out. So sine theta, 1 minus 2 cos theta is equal to 0. So we can see that sine theta is equal to 0, or 1 minus 2 cos theta is equal to 0, which means cos theta will be equal to 1/2. Consider solutions now to sine theta is equal to 0, 0, 180, 360. Consider solutions at cos theta is 1/2, 60, and 300 degrees. So all we've done is looked at factoring that now and gone ahead. Sorry, not 300, let's rewrite. Yeah, apologies, 300. So cos theta is 60 and 300. So all we've done is rewritten this, we factored it. We've expressed it as the product of sine theta now multiplied by the quantity 1 minus 2 cos theta and solve this. And we've just gone ahead and found these. So sine theta is equal to 0. We should hopefully start to recognise these. Cos theta is 1/2, again a special angle, as with many of these that we're looking at. Clearly that's not always going to be the case. So for example now, if I had, let's say we had sine theta is equal to, let's go for now 3 sine theta cos theta. Then what we could say then is sine theta, and then we'd have now sine theta, let's just rewrite that, I don't want to factor that, we'd have sine theta, and we'd have 1 minus 3 cos theta. So let's do that, sine theta, 1 minus 3 cos theta is equal to 0. So we'd solve for sine theta is 0, and we'd also solve for cos theta is equal to 1/3. So what we could say is the principal value would be now theta is equal to the inverse cosine. We're working in degrees of 1/3. So in a calculator, we would go ahead and get that. So inverse cosine now of 1/3, and then that gives us 70, and then we would do by symmetry 360 minus the answer to find the other one. So these are not our special angles or exact solutions. We're just considering now that cos x is equal to cos of 360 minus x. And of course all subsequent solutions would come multiples of 360 on from those. Okay, let's try something slightly more challenging. Let's go for now, and what I'm going to have tan theta. Okay, so if we have tan theta is equal to cos theta, and we will take now theta, and we'll go from 0 to 360. So again, a nice straightforward interval with this particular equation. Now with this one, we can see straight off graphically that there are going to be solutions. So if we consider this now, let's just go ahead and draw a quick sketch. If we have now tan theta, y is equal to tan theta, and we will take tan theta now from 0 to 360. So what we're going to do is come up. This is going to be my first asymptote. I'm going to have my first asymptote just here. That's going to be at 90. So let's now put on, we'll have the following. We're going up now around, this is going to be 180. So let's put that through there. Then we're going to come up now to the next asymptote, which is going to be just here at 270. So this is a quick sketch. Quite clearly we wouldn't solve the equation this way. I'm just showing now that there are going to be roots to this equation, and there should be 2 in the interval we're interested in. So this is now 90, we've got 270, we've got here 180, and we've got now 360. Now if we drew cosine at this point, what we're going to have is this point here. That's going to be 0. We're going to have 90. We're going to have now 180, where we've got -1, we've got 270, and we've got 360. So if I drew this on, let's go ahead and do that. What we're going to have then is the following. We'll come round, we'll come down, we'll come back up, we'll come through, and then we'll go back to the maximum here. So we can see that we've got these 2 points of intersection in the given interval. So how do we solve this? Well, let's think about now some identities that we met before. We've met cos squared theta plus sine squared theta is equal to 1. We've also met that tan theta can be written now as sine theta over cos theta. And this is what we looked at in the first video. So let's go ahead with this one. So what we're going to have then is sine theta over cos theta is equal to cos theta. I'm going to multiply both sides of the equation by cos theta. Sine theta is equal to cos squared theta. Next identity coming up. We know cos squared theta plus sine squared theta is going to be equal to 1. I want this in one trig ratio. I want it either sine or cosine. I can manipulate the right hand side to write this as a quadratic in sine theta. So we've got sine theta will be equal to now 1 minus sine squared theta. Okay, so that's what we've done. So let's put this in a quadratic. Let's have this now as sine squared theta plus sine theta, and then we're going to have minus 1 is equal to 0. So all I've done is simply written that. Now at this stage, if you're unsure, you can just say let p be equal to sine theta. So if we do that, what we're going to have is p squared plus p minus 1 is equal to 0. That's a quadratic in p. I can't factor it, so I'm going to go ahead and now complete the square. So let's just check that we've got all of this in place. That looks pretty good. So let's now complete the square. So what we're going to have then is p plus 1/2 all squared. I'm going to subtract away 1/2 squared, which is 1/4, and I've also got now minus 1. So that's going to give me 5/4, and that's going to be equal to 0. So I'm assuming by this you're fairly happy with completing the square. I'm simply going to write out the solutions now. I'm going to add 5/4 to both sides, take the square root, and then subtract the 1/2. So p is going to be equal to minus 1 plus or minus the root of 5/2. Okay, so this now is just solving. Again, you can use a calculator to solve that. Just looking ahead, that's what we're going to have. So we can say now that sine theta is equal to minus 1 plus root 5. So plus, let's just put plus or minus now root 5/2. Let's consider these two quantities. Now if I do on here, let's do this. If I do minus 1 minus root, let's just put that in correctly. Minus 1, there's minus 1, minus now the root of 5, so the root of 5, and divide this now by 2, we're going to end up now with minus 1.61. Sine theta now is between, it has a range from negative to positive 1. We can say that sine theta now cannot be equal to minus 1 minus root 5/2. Therefore, we can say now that sine theta is going to be equal to minus 1 plus the root 5/2. So let's go ahead now and look at this quantity right here. So if we do that, let's put that there, plus, I want a plus, that's what I want. There we go. So that number is between 0 and 1. So what we're going to do is take the inverse sine. We're working in degrees, shift sine of the answer. That gives me my principal value, so 38, and I'm going to say that's 38.2. So we can say now that theta is going to be equal to 38.2 degrees. That's given now to three significant figures. And then theta is going to be equal to 180 minus the 38 point ... Therefore, we can say now, just subtracting this from 180, so 180 minus that answer, and that's going to give me now 141.8. So I've given this one to three significant figures. I suppose we should really round it. Let's just do this one in the same. Generally, you would give them to decimal places, so three significant figures. But as stated, as we got that first one, 38.2, you might want to say to one decimal place for both. But as you can see, we've gone ahead and solved for those. And that's given us our two solutions. So that's that one just there, that's the lower one, and that's that one just there. So if we look at those, 142. So give or take, they're not brilliant. As you can see, it's a case of just sketching these. So it should be there. My apologies, I've put the minimum. So that looks about right, and that looks about right. Again, not massively accurate, but just gives us some idea. So that's a slightly trickier one, but all we've done is used now one of our identities to solve it. Okay, let's do one more. Let's look at another one. Let's take now 3, and then we'll have, let's go for 3 tan theta is going to be equal to 4 tan squared theta. We'll take theta, let's go from 0 now to 360. So with most of these are fairly straightforward. In later videos, we're going to work through a range of different equations and decide how to tackle each. Okay, so let's just now rewrite this, and what we're going to have is 4 tan squared theta minus 3 tan theta is equal to 0. Factor in the tan theta is a common factor. We're going to have 4 tan theta minus 3 is equal to 0. So we can see that tan theta will be equal now to 0. So if we consider a tan curve, we know that tan theta is equal to 0. That means that theta will be equal to 0 plus now another multiple of 180 plus another multiple of 180. So it's 0, 180, 360. We've got this one right here, and we've got now tan theta is going to be equal to 3 over 4. What we would do is get a principal value. Therefore, now principal value, what we're going to have is theta is going to be equal to the inverse tan of 3 over 4. Remember, tan doesn't have to now be between minus 1 and 1, as cosine and sine does. So let's go ahead and do that. So we're in degrees shift now, tan, and then we've got 0.75 or 3/4. Let's do that, and that's going to give us a principal value. So 36.8 and so on and so forth. So theta is equal to 36, and let's do this to one decimal place, 36.9, and then of course plus 180n. This now just cycles. We know the tan curve cycles every 180, so our subsequent solutions would be on from there. So that's quite a nice example to do. I think we'll do one more to finish with. Let's just do another one. Let's take now multiple angle. So let's go for now let's take tan squared 2 theta. So we have a quadratic, and we have now this multiple angle. Let's say that's 1/3. So taking the square root, tan 2 theta will be equal to plus or minus 1 over root 3. So this gives us now our special angle. We've got now 1 over root 3, which is going to be, well, let's take theta. Let's go now. Let's make this nice and easy. We'll take theta from 0 to 360. Now what we have here is 2 theta, and as discussed with the multiple angles, we could adjust the interval and say that 2 theta is going to be between 0 and 720. So let's get a principal value. So we could say now on here that 2 theta is going to be equal, if we take now the positive, in fact let's just write it here, let's take now positive root 1 over root 3. 2 theta is going to be equal to now, this is going to give us 30 degrees, and then what we're going to have then is 30, then we're going to have now 2 theta is going to be equal to 180 on, so that's going to give us 210. We've got now 2 theta, we're going to have 180 on, so we're going to have now, what's that going to be, 390, and so on and so forth. We would then go ahead and look at minus. Now if we consider this, what we're going to do is get a principal value of minus 30. So if you put that into the calculator, let's just do that, let's go ahead. When you put now, if you do the inverse tan of minus 1 over root 3, the calculator is going to kick out this value right here of minus 30 as the principal value. All we do is consider subsequent solutions, now 180 on. So we could say that 2 theta is going to be equal to, we're going to have 150, and so on and so forth. So if we added now a multiple of 180, let's go ahead and do that. We're going to have 2 theta is going to be equal to, what's that going to give me, 330. If we add a multiple of 180, what's that going to give me, 510. 2 theta is going to be adding a multiple of 180, 690. So then I'll just split them by 2, and of course I'd need to continue up with this one. We'd need to keep going. We would have now another 180 on from this, which is going to give me what, 570. Then the next one, 2 theta. If I add another multiple of 180, I'm going to go over. That's going to give me 750. So we could see that we're going to get theta is equal to 15. We're going to get theta is going to be equal to 105. And now you can consider these. With 2 theta, we can see quite clearly these subsequent solutions are going to be 90 on from each other. And we discussed this in a previous video. So 195 theta, then we can have now, what's that going to give me? 285. I'm kind of just adding 90 each time. So that's the first set. Now for the positive one, and then this one right here, we would just go ahead and split these by 2. So theta would be equal to 75, theta would be equal to 165, theta is going to be 255, and then the last one, theta, if we now just go up, that's going to give us 345. So they are the solutions. So I'm kind of thinking my maths has held up there. If not, hopefully you can see how it's done. So they are a range now of quadratic equations in sine theta, cos theta and tan theta. So all we do is use similar techniques to algebra. We solve now for sine theta, cos theta or tan theta, then consider principal value and then solve them like we would trig equations. With some of them, we do need to use trig identities to rewrite these. So check with your trig identities, see if you can manipulate it and work from there. So they are some basic examples. In later videos, we'll look when the solutions are slightly messier.